Okay, we got a Zenith Oceanic, Trans-Oceanic radio. I picked this up at a yard sale a while back, and it's got a little bit of from moisture. It's plugged in. I got a Variac here that's also plugged into an isolation transformer, and what the heck is that? Get very little, if anything, not so good. Okay. Put that out of its misery for now. Doesn't seem to be playing at all. I did take a quick look in the back. It looks pretty clean. Get this open with one hand. See if I can get this open with two hands. Okay. It does look pretty clean. The antenna works all the way as it should, which is nice to know. Yeah, it's pretty clean. There looks like maybe the battery compartment had overheated or cooked once. There's a blue burn mark in there, and I can't find my flashlight, but the tag, here's a tag. Of course, the only one tag I have is all boogered up, but anyway, I was able to get, I believe it's a model 5G40, and so I'm going to dig up some information on this, and we'll see what we could do. Thanks for watching. Here's the Trans-Oceanic out of the cabinet. Very easy to take out, I might add. It looks nice and clean. Test the tubes. You got a multi-gang filter capacitor here. I think it said 60, 40, 20, 200. Test the tubes. Let's see. There's a resistor down in there. Got to check. And there's a domino style capacitor here. They usually are good. I want to test that. This looks like a wax capacitor. And I'm going to set this down for a second. Alrighty. Lazy Susan. Alright. Do one of these so it'll fall off and land on the ground nicely. And this has been bypassed. Old stinky little diode in there. This dropping resistor, these leads to this have been cooked. So I'm going to have to check that out, make sure that's the right value. This has got to go. This has got to go. That's got to go. This has to go. That's got to go. Him. This guy. In there. Over there. Another old domino. Elmenco. I forget the name of those. This is same. There's another one. There's another capacitor back in there. That looks like a lot of fun to get at. Oscillator coil and all of the other resistors and what else? So, yep. And that's about it. I'm gonna have to test everything out. I don't know what's going on with these IF cans. If I could get to it while I'm working here, I'm going to take a peek inside. Make sure there's none of that silver creeping crud going on. Put on this cord is non-polarized, so we'll work on that too. Alrighty, there it is, and stay tuned. Okay, I've decided which end to start at, and it's going to be this end here. Seems to be the most difficult as far as getting to the components. So there is a capacitor down in there. I'm going to replace this guy. There is you can see this big long capacitor here underneath the oscillator coil. That's going to be Adventureland. And then these two resistors here. So that's the game plan for step one. And I made some drawings and took pictures, and I'm sure that that'll be of some help. So that's going to be where I start. Okay, I'm about to remove L22, the first IF transformer. Here is the identifying arrow on the bottom of the unit, the transformer, and this is terminal 1. This blue wire goes to pin 2 on valve V1. Number 8, number 1, blue jumper wire, pin 2. Terminals 2 and 3, no connection. Terminal 4, you have these 4 connections. I got them all tied together, soldered right here. That went to terminal 4. Terminal 5 is a bare jumper wire. It goes to pin 6 of V3. Here's 5. It goes to pin 6 of V3. A jumper, bare jumper. I erased my J. And 6 of 5, terminal 5. 6 and 7, no connection. Terminal 8, there's 2 connections. One is over to this coil, the RF coil, right here, this terminal. And another one goes to the bottom terminal on the volume control. And this cap here, I had to loosen this guy because this covers the whole mess, and it attaches to this little 2-lug terminal strip. I painted it, and I painted the end of the cap. And that cap is, where is that cap? Right there. Nope, that's resistor right here. Oh, wait a second now. Is that right? That should be terminal 8. Oh no. No, that's this one here, yeah. That's this cap. It's pin valve 2. V1. Terminal 1. So you got V1, terminal 1. That's that cap. And it goes over to the lug on that little terminal block. And that's it. So, thank you for joining me into Adventureland. I already did this IF transformer And on the disc, I got some still photos. You'll see I had to use an eraser and get rid of some of the crud on that capacitive disc. So thanks for watching the Zenith Trans-Oceanic radio. Continues. I got some parts on order. I didn't have a 12 microfarad cap. I didn't even have anything close, so that's why I had to order a few things. Alrighty, take care and thanks for watching. Okay, some of these components on the Trans-Oceanic are out of tolerance. Here's a 4.7 meg ohm resistor, and it measures 7.23 meg ohms. And just for the halibut, I want to see, even though this is out of circuit, I want to see if this capacitor and this resistor have any influence on the reading. So I'm going to do this and do that and cut it. Doink. Nope. No effect whatsoever. Okay. So that resistor, as with many others, has got to go. Thanks for watching. Wanted to go over a little progress here on the Trans-Oceanic. I started February 16th, it's March 6th. Actually, February 15th, it's March 6th. Replaced the components as necessary. I also took out and dismantled both of the IF transformers and cleaned the capacitive discs. This transformer here, L23, had a large disc, measured 170 picofarads. This one here, L22, only had a small section of capacitive material on a disc, nothing like L23, but I cleaned it up anyway. And you know, it's your normal Adventureland. Capacitors way under there and under there and all over the place. I found out that you have to, when you're reassembling, you got to put in some components, and then if there are no more connections to be made at the terminal, if it's maxed out, you got to solder it while you could get in there with the soldering gun. So it's like you got to rebuild it in layers. The routing of the wiring, I guess from the factory, is you know, we could all do a little better job. I don't know what's up with that. A couple of nice burn marks here through the wires, no extra charge. That wasn't me. Sure. This was connected down there. So I'm not even over in this section yet. There's another burn mark over there. No big deal, but I'm going to change those out. So next over is I've got to do the filter cap and all of these resistors and capacitors around V5 and V4. So moving along, as all of the tone controlled, those components, all of the components are either way out of tolerance or just within tolerance at the end of their, if you do a little math with the 10%, or the capacitors, I figured at least 20. I know they say the old ones you go as much as 40% over, but anyway, while I'm here, I'm going to freshen it all up. and see if we could get this baby percolating. Alrighty, thanks for watching. Oh, and by the way, there's a bag of goodies so far, and it's going to be stuffed with a lot more before I get done. Alrighty, thanks for watching. Okay, the Zenith 5G40. I got all of the mechanical work done. I changed the resistors and capacitors as needed. Get rid of the selenium rectifier, Mr. Stinky, and this dropping resistor. That was out of tolerance. This is a filter resistor, and it's there's two sections of 950 ohms each. So I used 2K and 2K in parallel, and the ohms came out to just about 950 because there's a little tolerance on those. That worked out good. The diode to replace the selenium requires a dropping resistor. Everybody knows that. And after many attempts, I started at 300 ohms while I monitored the B plus voltage and the filament voltage. After a few attempts, it came down to 150 ohms. Did the trick. It's supposed to be 3 watts. I got a couple of 5 watts in there. It's 275 ohm. I didn't have 150 ohm. And the B plus voltage was right at, I think it was 105. 104 point something change, and 1.4 volts on the filament voltage. So here's a bunch of the components, and the next step, I aligned the broadcast band, the AM section, and that came out well. Plays really good so far. The next is to do the short wave just in these coils, but this has got to be on and extended, the whip antenna, so I am going to put this back in the cabinet, and I'll be able to get at these from the back with this mounted, and I'm going to try it that way. Incidentally, down here, this is like a little swivel frame I got off of a stool. Might have been a bar stool, and put a piece of wood on it, and this is very handy for rotating stuff around to work on. Alright, so thank you for watching, and stay tuned. Hopefully we'll get to hear this operate soon. Okay, going to try to align one of the bands. 49 meters. Got the right button pushed. The dial is set to 6100 kilohertz, 6.1 megahertz, and we have the radio here. This is a 6100. This is a phase lock loop radio to try to set the signal generator. Okay. Actually, there it is. The radio wants to pick it up. Come on, you. Actually, this... Man. Close enough. And I got an antenna close to the antenna for coupling. And let me shut this off. Turn the radio up. We're not hitting the right button here. Whoa! That doesn't sound too good. And then we got to adjust. Maybe get a little station in there. Let's see if we could tweak this one here. Without my hand in the way. Dare put you through steps 2 through whatever. There's a whole bunch, but that was step 1. So the signal generator set to the frequency, and then you monitor the AC voltage coming out of the voice coil, and you adjust your tuning slugs so that you get the maximum deflection, and you go all the way down the list. Alrighty, thanks for watching. Here's the Trans-Oceanic all back together. Got it plugged in, and it seems to be working. Got the AM band broadcast.
Cloud-based platform. AmericanEagle.com is the proud certified Salesforce partner you need to ensure a smooth implementation of this powerful platform. Salesforce will give you a competitive edge and grow your business.
Yeah, it tunes the stations, you know, they're coming pretty good. I also, it's the middle of the day, so I tried a couple of the shortwave bands, 19 meters, all day. Just had some guy singing here before.
قال ابن منظور رحمه الله في لسان العرب النجم الثاقب الثاقب
There's another station over here. I don't know what that whistle is about. Probably something I did inside. Where was that other one? Well, anyway.
منه قول الحجاج لابن عباس رضي الله عنهما إن كان frente al coronavirus a pesar del
That's closer.
Vivan los médicos y enfermeras. Viva la solidaridad internacionalista de un pueblo que no se rinde ante las adversidades. Pati Muñoz Guerrero.
Uh-oh. Here's the time standard. Hours 46 minutes. Alrighty. And so it works.
Чтобы тебя интубировал гинеколог, сиди дома.
And I'm happy about that. The sound is pretty good.
But that was the reason why.
The volume is very good. I checked the current draw. It's supposed to be 0.15 amps when you're on the AC, and this was a little low, like 0.11 or 12, right in between. So I don't know why that's lower, but that's the way it is. So there you have it. I guess the main thing was I tested the tubes. They're fine. They were all good. And the capacitors, the old waxies, were leaking and out of value, and a lot of the resistors were too. They looked, I don't know, they looked like they were overheated or something, like all bubbled up, and so I replaced those. The selenium rectifier and the dropping resistor to get the right voltages. And it's a nice radio, so I'm happy the way things turned out. And if I could do it, believe me, you could do it. So take care during this crisis situation across the world with the COVID-19. Remember your basics, stay safe, and be happy as possible. And thanks for watching. N2TSO 73.